Hello everyone! Today we embark on a new journey to explore the universe. While we may not be experts in the field of astrophysics, we always strive to bring you intriguing information and, at times, surprising facts about the cosmos. Join us in uncovering new and fascinating truths in today's video. How vast is the universe? When asked about the universe, the first words that most people often use to describe it are immensely vast or infinite. However, just how vast is the universe and whether it truly is infinite is not known by everyone. And according to the most brilliant minds among the most intelligent beings in the universe, more precisely the observable universe, has a diameter of approximately 93 billion light-years. And with 1 light-year being the distance that light travels in a vacuum, approximately 9.5 trillion kilometers, then 93 billion light-years would be equivalent to around 883.5 quintillion kilometers. It sounds formidable, but with the current level of scientific and technological advancements of humankind, we can completely traverse from one end to the other of the universe in just 300 trillion years. On the Helios B, the fastest spacecraft ever recorded in human history, it achieved a speed of 252,792 kilometers per hour, approximately 70.2 kilometers per second, with the condition that the universe remains unchanged in size during the time we travel from one end to the other. To say so is because the figure of 883.5 quintillion kilometers is only a relative and temporary measure. At the very moment you are watching this video, the universe is still continuously expanding at a speed even faster than the speed of light, a topic we might delve into further in the subsequent sections. Yet, if we omit the term observable, the true vastness of the universe remains an issue that no one can currently ascertain. The Galactic War. In essence, the ongoing expansion of the universe is causing galaxies to gradually drift apart from each other. Many observable galaxies are even moving away from our galaxy at speeds faster than the speed of light. And that means, quite possibly, we won't be able to see these galaxies anymore in the future, because the light emitted from them will never be able to reach Earth. And if this is causing you some concern because it seems to violate one of the fundamental laws of physics, that nothing can travel faster than the speed of light, it's not entirely the case. Because while the galaxies themselves cannot move faster than the speed of light, the universe, more precisely, the space within the universe, is continuously expanding at a rate greater than the speed of light. From there, it propels galaxies within the universe, causing them to drift farther apart. Returning to galaxies, while most are increasingly moving apart, our Milky Way galaxy and Andromeda, a neighboring galaxy, are actually approaching each other at a speed of about 110 kilometers per second. And it is projected that they will collide in approximately 4 billion years, creating one of the most catastrophic explosions the universe has ever known, potentially annihilating all life, if it still exists in both galaxies at that time. Just kidding, I have to say that, in reality, the merger of the two galaxies mentioned above is quite peaceful, or you could call it a bloodless merger. In fact, the collision of two individual stars during this merger is considered rare or nearly impossible. Because even though the total number of stars involved in this merger is astronomical, reaching 1.3 trillion, with about 1 trillion from Andromeda and 300 billion from the Milky Way, the distances between them are still immensely vast. Take, for example, the star closest to us, Proxima Centauri, which is located about 4.2 light-years away from the Sun. For a more vivid comparison, if the Sun were the size of a ping-pong ball, Proxima Centauri would be about 1,100 meters away from that ping-pong ball. In this scenario, the diameter of the Milky Way would be approximately 30 million kilometers. And even though the density of these ping-pong balls increases towards the center of galaxies, the idea of two ping-pong balls colliding with an average separation of 3.2 kilometers, or two stars with an average distance of 160 billion kilometers colliding, is almost impossible. Of course, peaceful is always just a part of the picture. Even if not directly destroyed by the collision, Countless stars will be ejected from the newly formed supergalaxy during the prolonged dance of two supermassive black holes before their merger, forming a quasar or an active galactic nucleus, and releasing an enormous amount of energy equivalent to about 100 million supernova explosions. Another interesting piece of information is that during the process of our galaxy merging with our neighbor, there will be a young lad named Triangulum Galaxy standing by, watching from start to finish. It is predicted that he might have the chance to continue the make-love with the newly formed galaxy called New Cometa, or Medromeda. Pocket-sized black hole. In a simple and understandable way, a black hole, or a singularity, is a region in space-time where gravity is so intense that it prevents anything, including light, the fastest thing in the known universe, from escaping. The reason for saying that light is the fastest thing in the known universe is because current scientific theories tentatively suggest the existence of a type of subatomic particle called tachyons that could potentially move faster than the speed of light. Returning to black holes in terms of size, scientists classify black holes into three main types. Supermassive black holes, with their origins still debated, are often found at the centers of most galaxies in the universe. Stellar black holes are formed from the gravitational collapse of massive stars with a minimum mass that is about 20 times greater than that of the Sun. The final type is the primordial black hole, a theoretical type of black hole with a mass ranging from less than the mass of the Sun to approximately the mass of a human egg. And precisely because of their extremely low mass, these miniature black holes can only form naturally in extremely dense and non-uniform environments during the early stages of the universe, immediately following the Big Bang explosion. When saying can only form naturally, it's because theoretically, artificial black holes can be created based on a theory called the Schwarzschild radius. The Schwarzschild radius describes the limiting radius, and if the size of an object compressed is smaller than this value, it would become a black hole. To give you an idea, the Sun could theoretically be compressed and immediately become a black hole if we had a powerful and massive enough machinery to compress it into a sphere with a diameter of approximately 5.9 kilometers. Similarly, the radius of Earth when turned into a black hole would be 8.87 millimeters, and for the Moon, it would be 0.11 millimeters. Speaking broadly, anything with mass in the universe has the potential to become a black hole if we have a sufficiently powerful compression mechanism. This raises the question, if one day, emphasizing that it's a speculative scenario, humans were indeed capable of creating artificial black holes, what would happen? If unfortunately, a black hole the size of a peanut were to suddenly appear in your pocket, let's see. First, we need to determine what exactly the black object in your pocket is. A black hole formed from a collapsed object the size of a peanut, or is it a large black hole precisely the size of a peanut? In the first case, the black hole is only atomic-sized and would vanish in less than a fraction of a trillionth of a second, thanks to a phenomenon known as Hawking radiation. Accordingly, even though it is true that nothing, not even light, can escape from black holes, these mysterious entities in the universe are believed to continuously emit what is known as Hawking radiation, causing a gradual loss of both energy and mass over time. Scientists refer to this as the black hole evaporation, where smaller black holes are believed to vanish more quickly. And along with the black hole, you would also disappear, because it is calculated that for every gram lost, the radiation emitted from the black hole is equivalent to the explosive force of about 10,000 tons of TNT. That's equivalent to 2-3 of the explosive power of the little boy bomb dropped on Hiroshima in August 1945. Not stopping there. If the tiny black object inside your pocket is precisely the size of a peanut, it means you are carrying the entire Earth with a mass of about 5,972 billion tons with you. At this point, you will definitely die. However, as mentioned before, death will come so quickly that you won't even be able to realize it. Worse, the Earth and over 8 billion other people on the planet will also die along with you. Thank you all for accompanying us on this journey of exploring the universe. Don't forget to subscribe so you won't miss out on our upcoming adventures. Let's continue to explore and share the passion together. Wishing everyone a fantastic day, and we look forward to seeing you again soon.